Very good morning, one and all. Today we are going to see a problem on mesh analysis. Take down this problem. In the following circuit shown in the figure below, calculate V1, V2, and V3, and also we need to calculate the power delivered to R1, R2, and R3. So this is the circuit that is given for solving. So here you see the voltage source 125 volt is there. Here also 125 volt is there. So here resistance and here. So what they are asking is we need to calculate what is this V1, V2, and V3, and also power delivered to this R1, resistance R1, R2, and R3. Okay, so here three resistances there, R1, R2, and R3, and here also three resistances there, RA, RB, and RC. Okay, so for this we need to calculate what is the voltage, that is V1, V2, V3, and also R1, R2, and R3. Okay, so first we'll solve this problem by using mesh analysis, and we'll solve this by using the nodal analysis also. Let me see which method is easy for you, that you decide, and based on that you solve the problem. First we are solving by using the mesh analysis. So here I am considering three loops, because here three loops are there, na? Loop 1, loop 2, and loop 3, I1, I2, and I3, like that I am considering. So here, applying the KVL in loop 1. So in loop 1, if you are applying the KVL, so it is 125 minus, okay, so because the current is coming like this, so here raise minus to plus is raise. So raise is positive, so I am taking as 125 minus, here it is drop. Okay, I am considering this as drop. So drop is a negative, so minus 0.3 into I1. Next, minus again drop minus 9.2 into I1 minus I2. So here I1, here I2. So I1 minus I2 minus, here the current is coming like this. Here the current is going like this. So here I'm taking this minus, again it is drop 0.5. Here I1, here I3 is there. So I1 minus I3 is equal to 0. Just simplifying this, we'll get the equation as minus 10 I1 plus 9.2 I1 plus 0.5 I3 is equal to minus 125. Take this as equation number 1. Okay, so next is applying the KVL in the loop 2. This is the loop 2. So here I am applying the KVL. So here you see three resistance are there. All are drop only, because current is going like all are drop. So I am taking this as a minus 9.2 into I2 minus I1. Okay, 9.2 into I2 minus I1. Again minus, okay, again drop minus 11.6 into I2, 11.6 into I2. So again it is coming, current is coming like this. So again it is a drop. Drop is again negative, minus 19.2 into I2 minus I3 is equal to 0. Just simplifying this, we'll get the equation as 9.2 I1 minus 40 I2 plus 19.2 I3 is equal to 0. Take this as equation number 2. Next, again applying the Kirchhoff's voltage law in loop number 3. Loop number 3. So here the current is flowing like this. So if it is current is flowing like this, so it is minus to plus. So minus to plus means it is rise. So rise is positive. So 125 as it is we are taking. So again this is drop. Okay, again this 0.5 is there. Again this is drop. So 0.5 into I3 minus I1. So here you see 0.5 into I3 minus I1. So again it is drop. Drop is again negative, minus 19.2 into I3 minus I2. So again it is drop, that is 0.3. So minus 0.3 into I3 is equal to 0. So simplifying this, we'll get the answer as 0.5 I1 plus 19.2 I1 minus 20 I3 is equal to minus 125. So take this as equation number 3. Now, solving these three linear equations by using your scientific calculator, because if you solve by linear equation method, it will consume time. So directly we are going for the scientific calculator and solving the three equations, and we are calculating I1, I2 and I3. So while calculating, solving these equations and calculating I1 and I2 and I3, we'll get the answer as I1 is equal to 32.24 amperes. Next, I2 is equal to 20.03 amperes. I3 is equal to 26.29 amperes. So you just tell in the comment whether you got the same answer or not. Now, with this current values, we calculated the current here, current flowing here, current flowing here, and current, that is I1, I2, and I3. So with this current values, now the main objective is to calculate the V1, V2, and V3. V1, V2, and V3 that we need to calculate. That means what is the voltage here in this particular resistance point? What is the voltage in this particular R2 resistance? What is the voltage in this particular resistance V3? Okay, so resistance R3, that is V3, we need to find out. So we need to find out to calculate V1 and V2 and V3. So V1 is equal to, so V1, how to find out? V1 is equal to I1 minus I2, because what is the current flowing through this R1 is majority will do the mistake here only. So simply by closing the eyes, what we'll do is we'll take I1 as what is the current flowing through R1 is I1, like that we'll take, and we'll solve the problem, and the total problem will go wrong. So majority of you will do the mistake here. So the current flowing through this R1 is I1 minus I2. Okay, so I1 minus I2 is the current flowing through this R1. So I1 minus I2 into this R1. So that is the V1. Okay, so V is equal to I into R. So I is nothing but I1 minus I2 into R is R1 is 9.2. So that we are multiplying. I1 we already calculated 32.24 minus 20.03. Just substituting and simplifying, we'll get the answer as V1 is equal to 112.33 volts. Similarly, we are going to find out what is V2. So V2 is what here? Very easy. V2 is what? V2 is nothing but I3 minus I2. Okay, I3 minus I2 into this R2. Okay, V is equal to I into R. So I is current flowing through this R2 is I3 minus I2 into R2. That's all. So I3 and I2 already we calculated. Just substitute here and we can easily find out the answer. After substituting I3 minus I2 into 19.2, we'll get the answer as 120.192 volts. Similarly, V3. V3 is what? Now, as per the circuit diagram, don't write blindly. Okay, as per the circuit diagram, so the current flowing through this particular loop is here I2 only. So I2 is what? So because here there is no other loops here. So here also there is no loop. So only I2 current only will flow through this R3 also. So R3 voltage is nothing but I2 into R3. That's all. So I2 is what? So yeah, here I2 is what already we calculated 20.03 amperes into R3 is 11.6. Just multiply it, we can easily get the V3 as 232.348 volts. Now one part is over. We found out the V1, V2 and V3. One part is over. Now we need to find out the P1, P2 and P3, that is power delivered to the R1 and R2 and R3. So what is the formula for power delivered? Power delivered is I squared R. Okay, power delivered is I squared R. Okay, so I squared R losses. So I squared. So P1 we need to calculate. Where is P1 here? Yeah, so power here, this is the P1 power delivered to this R1 is P1. So P1 is I squared R. So here what is I? What is the current? Already we calculated, or otherwise you calculate separately. What is the current through this R1? Like that already we substituted, and or otherwise separately you calculate and substitute. Nothing wrong with that. So here is power delivered to this R1 is I1 minus I2 into whole square. That means I1 minus I2 the whole square. I squared into R. R is 9.2. That's all. So here, yeah, 9 point, yeah, here P1 is equal to I squared R. So I1 minus I2 the whole square into R1. So R1, So I1, I2 already we calculated. Just substitute it and square it and simplify it. You will get the answer as P1 as 1371.57 watts. That is the power delivered to R. Similarly, for R2, R3, we need to calculate. Now, what is the power delivered to R2? R2 is nothing but I3 minus I2 the whole square into this R2, that is 19.2. That's all. So we can get the answer simply. So yeah, power delivered to R2 is nothing but I squared into R2, that is I3 minus I2 the whole square. So I3 you just substitute, I2 you substitute 19.2, that is nothing but R2. Simplify it, you will get the answer as 752.40 watts. It's nothing but 0.752 kilowatts. In kilowatts also you can write, or directly in watts also you can keep. Nothing wrong with that. Next is similarly power delivered to R3. So power delivered to R3 here, resistance 3 here is I2 squared into R3. Okay, I2 squared into R3. So I2 squared into R3 is I2 you already know into R3. Yeah, I2 squared 20.03 squared into R3 is 11.6. So we'll simplifying it, we'll get the answer as 4653.93 watts. In terms of kilowatts, it is 4.653 kilowatts power delivered to R3. So this is the answer we got. P1, P2, and P3 we got, and V1, V2, V3 also we got. So majority of you will do the mistake here only. So you need to be very careful while doing this problem. You just tell in comments like whether you are getting the same answer or not. And one more method also I am going to solve. Okay, which method is easy? That is up to you. We want only answers. You just write the answers. That's all. You solve and write the answers. So I'm going to solve it by using another one method also. That is by using the nodal analysis. So here, same circuit I'm drawing here. So I'm taking this as a reference node, this point as a reference node, this point as a node number 1, node number 2, and node number 3. Okay, so we can't take this node and this node. So only 3 nodes are there. So already I explained in detail how to frame a node in the previous classes. If you want, you just watch that videos also and come here. So 3 nodes are there, one reference node is there. Okay, so current is coming like this and dividing like this. Say, for example, this I'm taking as I1, this is I2, and this is I3, like that. So again, in this node, the current is coming like this and flowing through this side and this side. And this node also, it is flowing because current is coming like this and it's flowing here. And one more current is coming and flowing like this. Okay, so 3 nodes are there. Now we are going to apply the Kirchhoff's current law. Previously we applied Kirchhoff's voltage law. Now we are going to apply the Kirchhoff's current law and going to solve this problem. So applying the Kirchhoff's current law, node 1. Okay, so incoming current, node 1. So here one voltage is there. So here we are taking as V1, voltage at this particular node as V1, and voltage at this second node as V2, and voltage at this third node as V3. So in the node 1, so always consider this voltage is more than this voltage. Okay, so 125 minus V1 divided by 0.3. 125 minus V1 divided by 0.3 equal to, okay, so incoming is positive, outgoing is negative. So, but here we are taking equal to. So that means current is entering here and dividing into two. Like that also you can take, or otherwise you can take like minus of V1 minus V2 divided by 9.2. Next minus of next in this node, say for example this node, V1 minus V2 divided by 9.2, and one more here it is there, V1 minus V3 divided by 11.6. That also you can take. So minus of also you can take, or otherwise equal to also you can take. So either way it's good. So I have taken in this problem, I have taken like this. No sir, for me this is simple. Like that, you take minus of this particular, minus of this particular term. Like that also you can do. Just you need to simplify. Simplify with your scientific calculator is very easy. After simplification, we'll get the equation as 416.67 equal to 3.524 minus 0.108 V2 minus 0.086 P3. Okay, so here I missed V1 here. So 3.524 V1. Okay, here V1. This take this as equation number 1. Next, applying the KCL at node number 2. Now we are applying the at node number 2. Node number 2, if you see, yeah, here V1 minus V2. So here V1 is there, here V2 is there. So in node number 2, this also one resistor is there. So V1 minus V2 divided by 9.2 is equal to, okay, next V2, okay, minus 0 divided by zero point 0.5, because this is the reference node. The reference node with 0. So V2 minus 0 divided by zero point 0.5 plus next here V2 minus V3 divided by 19.2. Okay, because this current is incoming, these two currents are outgoing. So incoming you take as positive and outgoing you take as equal to that side, right hand side, or otherwise minus of you take, no issues. So like that we took here simplifying, and next is just simplifying. So if you simplify all this with your scientific calculator, we'll get the answer as 0 0.0. This is all mathematics. Okay, so you can have your own ideas. So whatever the shortcuts you have, you solve it and you come to a one equation format. Okay, but ensure that first you have V1, second you have V3, and third term you have V3, like V1, V2, V3, like that. Because while solving in scientific calculator, it will be very easy for you to type the values. That's all. So I'm segregating V1, V2, and V3. So after segregating, we'll get the equation as 0.108 V1 minus 2.16 V2 plus 0.052 V3 is equal to 0. Take this as equation number 2. Similarly, applying the KCL at node number 3. Node number 3, here you see V3. Okay, so one current is coming like this. Okay, so one current is coming like this. So one, how many currents are there? One current is incoming, two current, sorry, yeah, one current is incoming. Here also one is incoming to this node, and one current is outgoing. Okay, so here outgoing. If you take this as outgoing, this is yeah, um, node number 3. No, yeah, node number 3, V3 plus 125 divided by zero point 0.3. So V3, yeah, this is V3. So this is 125. So here you see, here one voltage is there. Here 125 is there. 125 also there. So this voltage I'm taking as more V3 minus 125, sorry, plus 125. Why? Because the term the, plus minus you see. So here it is minus, here it is plus. Okay, previously here it is positive because this battery source is supplying like this. But now you see this voltage source with respect to this voltage source, this is positive. Okay, so previously this we have taken as more voltage, or otherwise in reverse way you take. Okay, so in reverse way if you take means it will come like 125 plus V3, okay, like that, or otherwise minus of you take, minus of minus here if you it comes this side, minus of 125 minus V3 divided by zero point 0.3, like that also you take. So I have taken here as V3 um, V3 plus 125 divided by 0.3. Next, I have taken as V2 minus V3. So it is incoming now. So V2 minus V3 divided by 19.2. So one more current is also there, plus V2 minus V3 divided by 11.6. Okay, so V2 minus V3 divided by 11.6. 11.6 V2 minus V3 divided by 19.2 is equal to V3 plus 125 divided by zero point 0.3, or otherwise because it is going out, no, it should be negative. So it is minus V3 minus 125 divided by zero point 0.3 also you can take. So simplifying this, you will get the answer as 0.086 V1 plus 0.052 V2 minus 3.46 V3 is equal to 416.67. Take this as equation number 3. So solving this three equations, where this one equation, two equation, and the third equation, we'll get the answer V1 as 115.46 volts, V2 as 2.94 volts, V3 as minus 117.51 volts. But this is the voltage what we got from this equation, but it is not actual voltage. But as per the circuit, V1 is equal to, so you see here, as per the circuit, this V1 is equal to, where is V1? Yeah, so here is V1, no, 9.1 V1. So V1 is equal to V1 minus V2. So here you see V1 is equal to V1 minus V2. V2. Okay, this voltage. So we need to find out the voltage in this particular this resistance. So V1 is equal to V1 minus V2, because you see the nodal analysis. What is the voltages at this point means V1 minus V2, sorry, V1 minus V2. Okay, so V1 we calculated, that is V1 is 115.46 minus 2.94. So if you simplify this, actual V1 is 112.52 volts. Similarly, V2. So V2 is nothing but, so this here it is V2. So V2 is nothing but V2 minus V3. So V2 minus V3 is nothing but, so V2 already there na, 2.94 minus V3 is 11 minus of minus 117.51. So minus of minus 117.51. It is 120.45 volts. Similarly V3. So V3 is, here you see V3. What is V3? So V3 is V1 minus V3. So V1 minus V3 is V3. So V3 is V1 minus V3. So V1 is what? 115.46 minus of minus V3 is 117.51. So if you simplify, you will get the answer as 232.97 volts. Okay, so this is what we got as V1, V2, and V3. Now we need to find out what is the power delivered. So power delivered P1. Okay, so power delivered P1 is equal to I squared R. This you know, I1 minus I2 the whole square into R. Or otherwise nothing but V1 into R, V into R. That also you can write. So this V1 into R, that also you, if you do, same answer will come. Or otherwise I1 minus I2. So here we found out, here we didn't found out I1, because from the previous formulation we have I1. So otherwise V into R. Okay. Sorry, V squared by, sorry, V by R. So I is equal to, so V is equal to IR, no? So I is equal to V by R. So V by R the whole square. Okay. So the voltage divided by that R, that resistance, the whole square into the particular resistance. That also you can take. So if you calculate that also, you'll get the same answer. Just tell in the comment whether you got the same answer here also. So if you take like V by R the whole square into R, you will get the same answer, that is power as 1371.57 watts. So it's nothing but 1.37 kilowatt. So that is means power delivered to R1. Similarly, power delivered to R2 is nothing but P2 is equal to V by R the whole square into R2. So that the voltage V2, whatever the voltage in that particular resistance, that means V2, no? So V2 divided by R2 into R2. So the same thing. Next, power delivered to R3, same. If you calculate, you will get the answer as 52.40 watts, or otherwise 0.752 kilowatts. Similarly, the power delivered to R3 also, you will get the same answer, that is V by R the whole square into R3. So you'll get the power delivered to R3 as if you calculate, you'll get the same answer, that is 4.653 kilowatts. So this answer and that answer is same or not, just we'll verify. So 4.653, 0.752 kilowatts, here 4.653 kilowatts, and 1.37 kilowatt. So here also V1, V2, V3. So if you verify this nodal analysis with the mesh analysis, we'll get the same answer, because here you see 4.653 kilowatt, here also 0.752 kilowatt. Here we got 1.737 kilowatt. Here also V1, V2, V3 also we are getting almost same, 112.33, 120.192, 232.348 volts. So we are getting the same answer for the both the methods. So hence this proof. So now you decide which method will be easy for you to solve, and you further proceed and solve this problem. This is how you need to solve the problem. Here you need to very careful what is the current flowing. That is one tricky here. Otherwise, all same. It's very easy to solve and attain the answer.